The story of this gold ring is long and difficult. In fact, rephrasing Carl Sagan, in order to create this gold ring, you must first invent the universe. Let me take you on its journey through iron and fire. Hydrogen and helium are the smallest atoms and were created shortly after the Big Bang. To create larger ones, we need to fuse them together. The only problem is that the protons inside the different atoms repel each other because they have an identical electric charge, and yet heavier elements are created in stars, where the density and heat is so high that the atoms collide strongly enough to overcome the proton repulsion and fuse. This fusion requires some energy, but it produces even more and creates increasingly heavier elements until iron. It stops at iron because at this point, the proton repulsion is so high that fusing iron together would require more energy than it produces. Without the fusion, the star no longer has outward pressure, and it can't resist its own gravity, causing it to collapse and may result in a supernova. In supernovae, the stars collapse towards their core, and their outer layers are ejected into space in a giant explosion. But even this explosion isn't strong enough to overcome the proton repulsion in iron. So what if instead we had neutrons? Their neutrality allows them to enter the nucleus more easily. Perfect, except for one problem. Neutrons aren't stable, and outside of a nucleus they only last about 15 minutes before they decay. And even in a nucleus they decay, although slower. That's why we need an extremely rapid process in which there are so many neutrons entering at once that they enter faster than they decay. Think of it like a bucket with a hole in it. If you put in water slowly, it will never fill up. But if you quickly put up a lot of water at once, it will fill up. And that's why we need a huge amount of neutrons, which brings us back to supernovae. During the supernova stage, the star collapses towards its core, and if it's large enough, its atoms are pushed so close together that the electrons merge with the protons and form neutrons. This core is now a neutron star. Neutron stars have more neutrons than anywhere in the universe, almost perfect for the creation of heavy elements, but not quite, because those neutrons are stuck in a star far away, and they're also too close together to form individual elements, which brings us to our next step, neutron star mergers. Even rarer than one neutron star is two of them orbiting each other. But it happens. As they orbit each other, they emit huge amounts of gravitational waves, which causes them to lose energy and begin spinning towards each other. This continues until boom, they collide. This is when rapid neutron capture, which we talked about, happens. When the stars collide, the space near the collision is bombarded with neutrons from the star, separating them and sending them across the universe. Those neutrons enter leftover iron atoms and cause the neutron count to increase, while the proton count stays the same. And then, something happens. A neutron undergoes beta decay and emits an electron, leaving behind a proton, which is why the neutron count goes down and the proton count goes up. That's how heavier and heavier elements are made. But today, we'll stop at an atom with 79 protons and 118 neutrons. Gold! We did it! Oh, and this ring? Well, that's a story for another day.